Hello, students. Good morning. Today's topic is electric flux. So, before starting this topic, let us see something about a well known quantity, and this quantity is, say, area vector. As we already studied about area in the earlier classes, that area is a scalar quantity. Okay, but when this scalar quantity is represented by some directions, then it becomes a vector and hence known as an area vector. For example, if we have, say, a spherical surface with center, say, O, then let us consider a small portion, or we can say small portion of the surface of this sphere. Then what is the direction of this sphere, or we can this surface? As there is area, say it is dA, small area of this surface, then a vector drawn perpendicular to the surface. Now a perpendicular to this surface is a line joining the center. So we can say this vector, say n cap, this vector represent the direction of this surface, and hence this area may be written as an area vector having direction normal to the surface. Okay, similarly, if we have a plane surface like this, okay, then it must have a direction that is perpendicularly outward. If it is vertical plane, then a perpendicular direction is along x-axis, so this is the direction of this area vector. Okay, similarly we can say each and every area having directions which is perpendicular to the surface of that area, so we can deal the area as a area vector. Now come back to our topic, that is electric flux. So what is that flux is? According to definitions, the flux is the number of electric field lines electric field lines passing through a surface normally or perpendicularly. Okay, it is denoted by a Greek letter phi. Okay, so what is the meaning of that line? That we also know that if, let us consider, there is an electric field like this, as it is in uniform electric field, then the parallel lines equidistant with each other represent the uniform electric field, and arrow headed show the direction of this field. Now if in a uniform electric field, if we place any object like this, then these electric field lines passing through this object, or we can say from here, if we see that there are four number of lines passing from this surface, and now here what is electric flux? The number of electric field line passing through the surface normally, the lines which are passing through the surface normally. Now what is the normal of this vector? Say this area, say this area is a, and its direction is shown by an arrow perpendicular to the this surface. So normal is in the line of electric field, so we can say all the four electric field lines are passing through the area, and hence these lines are the electric flux through this surface. Okay, now on what factor this flux is depend upon? Okay, first of all, flux is depends upon electric field, whether it is weak or strong. Means if there is a field like this, there are four number of line passing through this. If the electric field is strong, means there are large number of lines passing through the same area, like this. Okay, it means there are large number of lines passing through the same area, so we can say it is increase, or we can say flux is increase with increase in electric field, or it is decrease with decrease in electric field. The second one, flux is also depends upon the area of the surface. Okay, as we know that if we consider say an electric field like this. Okay, so now if we consider an area, say area A1, okay, having normal in the direction of field, then and suppose in the same field if we have another area like A2 in the same direction. Okay, so it is clear that from area A1 there are large number of electric line passing through normally, and in the area A2 there are lesser number of electric field line passing normally. So flux through surface A1 is greater than the flux through the surface A2, and hence we can say flux depends upon area. Okay, now another one term is that flux is also depends upon the orientation of this surface, or we can say the direction of electric field passing through the surface. For example, let us consider the electric field in this direction. Okay, and consider the flux is say surface is oriented like this. Okay, so the normal to the surface is say in this direction, n cap. So electric field is inclined at an angle theta with the normal to the surface. So how many number of lines are, or we can say what is the amount of electric field along the direction of normal. So if this angle is theta, so along this line, or we can along the normal, there is a cosine component of electric field. So we can say in the direction of normal to the surface there is e cos theta component only. Okay, so if we combine these terms we get phi is equal to e into a, that is field into area. Okay, but when surface is inclined at some angle, okay, or we can say if the orientation of surface makes some angle to the between electric field and normal to the surface, then what is the electric field along the direction of this area? So we can say electric field is represented by a component e cos theta. So e must be equal to e cos theta into area, or we can say electric flux must be equal to E A cos theta. Say it is equation first. Okay, also as we know that here A is a vector, that is the electric field, and area is also a vector. So and theta is the angle between these two, so we can write it in the form of vector, that is vector E dot vector A. E dot A, say equation second. Okay, now as it is clear from the equation second that there are two vectors and there is the dot product of these two vectors, so dot products gives a scalar quantity, and hence flux, or we can say electric flux, is also a scalar having units. What are the units? Electric field units are Newton per coulomb, and that of area is meter square. So units are Newton meter square per coulomb. Okay, now as it is clear from equation first that phi is depending upon the theta. But as we consider there are three surfaces, these are the plane surfaces, but each and every time the plane should not be surface should not be plane. So we consider some arbitrary surface, that is like this. For arbitrary surface, that is like this, if we have say this surface, okay, so let the surface is placed in that electric field which is along these lines. Okay, so how we calculate the total electric flux passing through the surface? So we consider this surface as consist of large number of these small segments like this. So the surface, this surface, small surface having direction normal to the surface in outward direction, and hence the angle between this electric field and normal to the surface is theta. Okay, similarly if we consider a surface here, then it is having direction of normal is like in this side, so the angle between electric field is this, it is again greater than 90 degree. Similarly at this point if we consider the surface like this, then the normal is in this direction, and hence the direction between electric field and normal is theta, which is less than 90. Okay, similarly we consider this surface consists of small surface element, and hence knowing the values of thetas we can calculate the flux, and then we can add all these surface elements. Okay, so the summation of all the flux gives the total flux passing through the surface. Okay, as it is clear that here, that is at outward section the angle is always less than 90, so flux becomes positive, because if angle theta is less than 90, then cos less than 90 must be positive. Okay, but as a in inward case theta is greater than 90, okay, so flux must be negative. So when we add all these, so outward flux must be added with the inward, so inward flux is subtracted from the outward flux, and if this flux is not equals, then we get the balanced flux known as the total net electric flux passing through this surface. Okay, so we can also write the flux must be equal to the flux due to all these surface elements. Let these surface elements are considered ds, or we can say dA, so we can write here E dot dA. Okay, as it is a vector quantity, so we can write A dot dA for a small, but if we consider the total flux, then we can add all these, or we can say addition is proceed with the help of integration over a closed surface. So we can write total flux as integration of E dot dA. So this is equation third. Okay, so that's all about electric flux. Thank you very much.